Chapter 1, Real Numbers and the Coordinate Plane. Section 1, Day 1, so there will be a Day 2, is rational numbers. Our objective is to write equivalent fractions in decimals. Our new vocabulary will be rational number, terminating decimal, and repeating decimal. Let's start with defining our vocabulary. A rational number is a number that can be written in the form a over b, where a is an integer and b is any non-zero integer. So basically, a rational number is any number that can be written as a fraction. This includes terminating decimals, repeating decimals, and integers. Well, what are terminating and repeating decimals? A terminating decimal is when writing the decimal expansion of a fraction, the division results in a decimal that stops. This just means it's a decimal that stops. A repeating decimal is if the decimal expansion repeats the same digit or group of digits forever. So it just repeats on and on and on. A quick refresher, what is an integer? An integer is any number that are the positive or negative whole numbers, and zero. So integers are any number basically that does not have a decimal or fraction attached to it. So let's quickly refresh how to reduce fractions. If I've got 12 over 30, I find the greatest common factor of 12 and 30. That would be 6. So I'm going to divide the top and the bottom by 6. 12 divided by 6 gives me 2. 30 divided by 6 gives me 5. That fraction reduced to 2/5. 18 over 24, the greatest common factor here again is actually 6. 18 divided by 6 gives me 3. 24 divided by 6 gives me 4. So my fraction reduces to 3/4. So we're talking today about how to turn fractions into decimals and decimals into fractions. To turn a fraction to a decimal, you're going to use long division to divide the numerator by the denominator. To change a decimal to a fraction, you're going to write the digits to the right of the decimal as a fraction. The denominator will be the place of the last number. So for example, if the last digit is in the hundredths place, it means your denominator will be 100. And then you'll have to simplify. So we're going to change a couple fractions into decimals quickly. 1/2. Remember, the 1 will go under the division, the 2 will go outside. 2 does not go into 1, so we have a 0. And we'll add our decimal and a 0 after that. 2 goes into 10 5 times. I get my 10 and nothing left over. That means 1/2 is equivalent to 0.5 or 5/10. 1/8 now. My 1 goes, sorry about that. My 1 goes under the division. And the 8 goes outside. 8 doesn't go into 1, so I add my decimal. 8 goes into 10 one time, which gives me 8. And I subtract with 2 left over. Remember, we don't like remainders. So I add a 0 and bring that 0 down. 8 goes into 20 2 times. That is 16. I subtract and I get 4. Add another 0, bring it down. 8 goes into 45 times, and that is 40. So I am left with nothing left over. My final answer, 1/8, is equivalent to 0.125. For 3/4, I'll switch colors here. 3/4, the 3 is going to go, I apologize. The 3 is going to go under the division, inside of there, and the 4 goes outside. 4 does not go into 3, so I put my 0, add my decimal and a 0 after. 4 goes into 37 times. 7 times 4 makes 28. I have 2 left over. Add a 0, bring it down. 5 times 4 makes 20. And I'm left with nothing, which means that 3/4 is equal to 0.75. And for our last one, we have 1/5. My 1 goes underneath. My 5 is outside. 5 doesn't go into 1, so I add my decimal and my 0. 5 goes into 10 2 times. I subtract with a remainder of 0 right away. So my answer is 0.2. Now let's change decimals into fractions. To change a decimal into a fraction, our rules said that we write the numbers to the right of the decimal. Those are going to be our numerator. Over, our denominator is the place of the last number. The last number here is the 5, and it is in the hundredths place. Now we have to simplify. I know that 25 goes into 25 and 100. So this simplifies to 1/4. For 0.7, I write my 7. My denominator in this case is a 10, and that one does not simplify, so I am done. 4, or 0.4, 4/10. I write it as 4 over, you guessed it, 10. This reduces by 2, so we divide the top and bottom by 2, leaving me with 2/5. And our last one is 0.15. That will be 15 over 100 because the 5 is in the hundredths place. And I know that 5 goes into both of these. So I'm going to get 3 over 20, 3/20. Now the next thing is an application. In baseball, a player's batting average is the number of hits over the number of times at bat. Batting average is rounded to 3 decimal places and is written without the leading 0. So we're going to find the batting average of a player with 36 hits and 125 times at bat. That fraction would be 36 over 125. So we have to turn that into a decimal. Remember, the 36 will go underneath, the 125 will go outside. We know 125 doesn't go into 36, so we'll add a 0. How many times does 125 go into 360? I would say 2. 2 times 125 is 250, leaving me with 110 left over. Add a 0, bring it down. How many times does 125 go into 1,100 is the question next. We have to think about it. When we're thinking about it, I would think 8. 8 times 125 is 1,000. So we're going to subtract, and I have 100 left over. Add a 0, bring it down. Well, I already figured out that it's 8. So I have my 1,000 here. I will subtract and, I will subtract and be left with, wow. When I subtract, I'm left with a remainder of 0. That means my answer is 0.288, but batting averages are written without the beginning 0, so it is a 0.288 batting average. So now you're going to find the batting average of a hitter with 22 hits and 80 times at bat. Remember, this would be 22 over 80. The 22 goes underneath. The 80 goes outside. 80 doesn't go into 22, so I add my decimal. This first number, how many times does 80 go into 220? I'm going to think 2. It's going to be 160. I have 60 left over. Add a 0, bring it down. How many times does 80 go into 60? I'm going to go with 7 because that will be 560. Subtract, I'm left with 40. Add a 0 on the end and bring it down. This one will be 5 because that'll equal 400. And we are left with a remainder of 0. So the batting average will be 0.275. Now we are going to write 27 over 99 as a decimal. To start, let's make it a little simpler. We know that 9 goes into both 27 and 99. So this reduces to 3/11. Now this makes our problem just a touch simpler, so we can divide more easily. We're dividing 3 by 11. Add my 0, my decimal. I know that 11 goes into 30 2 times, which makes 22 with 8 left over. Add my 0, bring it down. That'll be 7, 77. Scroll down a little bit more, give myself some more space. All right, I have a remainder of 3. I'll add a 0, bring it down. That'll be a 2 again, 22. I subtract, I have 8 left over. Add my 0, bring it down. 77, 77. At this point, hopefully you're noticing that it's going to keep repeating. 3, 8, 3, 8 left over on the bottom there. Which means the top here, our answer, is going to keep repeating 0.272727. My answer is 0.27. Both the 2 and the 7 are repeating. So we're going to write 55 over 60 as a decimal. Let's reduce it first. I know that 5 goes into both of these. I'll get 11 over 12. Let's divide. 11 divided by 12. Add my 0, my decimals, my extra 0. All right, 12 goes into 110 how many times? I think 9. 9 times 12 is 108. I subtract, and I have 2 left over. Add a 0, bring it down. 12 goes into 20 once. I'm left with 8. Add a 0, bring it down. How many times does 12 go into 80? Well, I know that 12 goes into 72. So 6 times 12 makes 72. Left with 8. Add another 0, bring it down. Oh, 80 again. Let's go with 6 again. 72, subtract. I'm left with an 8. And at this point, you might notice that the 6 is going to repeat on my answer. So my answer is going to be 0.916 repeating. Now let's write 1.345 as a mixed number. We're actually not going to write it as a mixed number. We're going to write it as an improper fraction. So we're going to write our number without any decimals as the numerator. The denominator will be the place of the last number. The last number is the 5, and it is in the thousandths place. Now we reduce. We know 5 goes into both of those because the top one ends with a 5, the bottom ends in a 0. 1,345 divided by 5 is 269. And 1,000 divided by 5 is 200. And that is as simple as it gets, and that is your answer. Now let's write 1.42 as a mixed number. Actually, we're going to write improper fraction again. So 142 over, the 2 is in the hundredths place. What number goes into both of these? Well, I know 2 does because they are both even numbers. 142 divided by 2 is 71. And 100 divided by 2 is 50. That's as simple as it's going to get. So just a quick note, all decimals that terminate or repeat have a fraction version. And all fractions have a decimal version that terminates or repeats. So all rational numbers can be written as a fraction, either a decimal that terminates or repeats. Your assignment is worksheet 1-1.